Here we go. Start recording here. Yeah. Well, that's way to get your bonus points for sure. Hi, Max. Thank you. Milda, Vincent. You guys can get in there. Ilani, Ava. Thank you much. Get started here in a minute. Thanks, Braden. So this is ion review. So if you remember what ions are, okay, let me just kind of briefly remind you. So ions are there are two different varieties. So ions are charged elements, right? Ions have a charge, either a minus or a plus charge, right? And that has to do with the electrons only, right? Does not have to do with the protons, electrons, okay? And anybody remember what the positively charged ions are called? Can't hear you. I'm going to rejoin. Cations. All right. Yes, cations. Right. How about the ones that are onion? I love science. How about the ones that are onion like? Ah, here you go. Anions. Excellent. Okay. So let's get started here. You guys are doing great. Let me turn the music off so you don't hear too much of it. So let's get started. Thanks for getting in there. Thanks, Gage. What's an ion? An atom with a positive or negative charge, a neutrally charged atom, an atom with more neutrons than protons, an atom with different number of protons. 8 people here. Hey, Dahlia. You guys can join late, so just hit the link there, okay? Vincent, you guys can join late. 7. Did I get all 8? All right, we're moving on. How'd you guys do? Excellent. Adam with a positive or negative charge. Who's in first? Braden, good job. Woohoo! Get ready. 10 questions here. What's a cation? A full valence shell, a neutral ion, a positively charged ion, a negatively charged ion. How are we doing on that? You guys can get in. Come on, Emily, Dominic, click on the link. It's also in the shared notes. All right. How'd you do? Good. Positively charged, 75%. Who's in first? Max. Good job, Max. Kaylee, Braden, you just moved to third. We got 7 more questions, 8 more actually. What's an anion? Negatively charged ion, a neutral ion, a positively charged ion, all ions. Remember your onion. Oh, it's negative. Right, it's negative. Oh, you got 10 people in there now. Great job. All right, you got half the class. All right. How we do? 60% negatively charged ions. Remember, cations are positive. Kaylin, thank you. And anions are negatively charged onions. All right. Okay. Oxygen. How many valence electrons? Remember how that works. You can see that's what we're going to be talking about today. Valence electrons are the electrons that do the bonding, which by this periodic table model, which is at 3, 1, 6, or 7. Not 16 for sure. All right, 7 people, 8. All right, let's see how you guys did. 70%, 6. Okay, remember it's that bottom number in that chart, bottom number on those numbers of the number charts. Okay. How is an ion formed? Only when it gains an electron, it shares a neutron, it loses a proton, it gains or loses an electron. Which one is that? 7, 8. You get 9? Nope. Gains or loses electrons. Wow, you guys are great. Kaylee, Dominic. Thank you, Dominic, for getting in there. Excellent. Potassium, how many valence electrons? Remember, 2881. The last number is your valence electron. Remember that. Last number is your valence electron. 8371. It is number one, right? 60%. Remember, you got to look at that last number in the row of four. It had four shells there, and the last one was how many valence electrons. We don't worry about those others, right? So how many valence electrons here for boron? Is it 5? Is it 3? Is it 2? Is it 1? All right. It is. How many do you do? Ooh, some people put 3, which is correct. All right. Okay. And let's see here. Kaylin, Matt. Ooh, we're moving around. I'm moving around. I didn't realize we moved around that quickly there. Our lithium has 3 protons and 2 electrons. Now, if you're using your calculator, you put 3 plus a -2. You can do it that way because you're adding the 3 protons and 2 electrons. What charge do you get? 3, 2, 1, or -1? We doing 50%. It's a +1. 3 plus it's 3 minus 2 if you want to do it, or 3 plus a -2 gives you 1. Max, Kaylee, Angela, thank you for getting in there, Angela. Thank you, thank you, thank you. 8. This is the last 2 questions. 17 protons, 18 electrons. So if you can see that it has more electrons, then it's going to be a negative, right? So is that a +1 cation, -1 anion, +35 cation? How'd we do? 50%. So that's the anion. We're adding a little level of difficulty. Max, Kaylee, Gage, third place. Last question for all the marbles. Nitrogen has 5 protons, 8 electrons. What's the charge? Is it anion or a cation? Remember, anions are onions. That's a negative. Cations are positive. So it has more electrons than it does protons. So it's going to be a -1. How did you guys do? Well, 50%. 3 minus anions. Okay, so you guys are still struggling with this. Aaliyah, third place. Kaylee, second place. Max, first place. Excellent. Whoa, look at that. 100. You guys are pretty close. All right, so today we are going to go over, let's see, am I on the right? Here we go. Week 8. Okay, so week 8, there's a chapter test. That's why we're going to go over Lewis.notes, Lewis.guided notes. Okay, so this is a link here. So I'll give you this to you. All right, so if you guys will follow along with me here. So 10.8 guided notes. Guided notes. There we go. V. So this is all about Lewis dot. Let me give you the link here. There you go. And let me copy that, put it in the shared notes just in case other people come in. While I'm waiting for those people to come in, if they are here, let me say hello to those people that are here. So Angela, hello. Tim is away. Austin, Ava, Braden, good afternoon. Dahlia, Destiny, Dominic, Eden, good to see you. Emily, Gage, Hunter, and we've got Jelani, Jameer, Joseph, Caden, Kaylee M, and Kaylee C, Kaylin L, Liam, Mackenzie, Max, Nevea, Nilda, Vincent, and Vito. Excellent. Okay, so here's where we're going to go. Tell me that you are in there. 10.8. Okay, so this is the slideshow for today. All right. Peter Pan and Tinkerbell. right? Where there is a chapter test, 60 points this week. So that's why we're doing all this review. Thanks, Kaylee. Thank you very much, Nilda. Thanks, Eden. All right, so homework, give you some chance to do this. We'll get done here at, let's see, we're going to stop here at 1:15. So you got 15 minutes to work on some homework. All right, I can count valence electrons, okay? We'll be practicing that for several weeks. Isotopes, not so much, and Lewis dots, not so much, but you do have to remember the valence electrons. Okay, so remember atomic mass. Anybody tell me what is atomic mass equal to? So let me give you the P plus what? P plus what? Let me put this in the question mark here. Question mark in the chat. Anybody know what this is? Where's my question mark? There we go. Atomic mass is P for protons plus what? N for what? Thank you. P plus N, right. Neutrons, thanks, Max. Yeah, protons plus neutrons. That's where all the mass is. It's in the nucleus. The atomic number 6. So how many neutrons does this have? Neutrons, N-E-U, trons does this have? Question mark. How many neutrons does carbon have? Anybody know? So we have 6 protons plus something equals 12. So 6 plus what gives me 12 neutrons? 6. Thanks, Max. Yes, it is 6 plus 6 plus 6. So if we're looking at this, turn my pen on. So protons plus neutrons here, right? Right. And we already have the 6 in here. So we already know it's 6 plus some number. Oops, not times some number. 6 plus some number gives me the number of neutrons. And we also know that carbon, the proton count is always going to be the same. So we've been talking about ions. Ions change the electrons and the charge. Now we've talked about isotopes, and isotopes have a different number of neutrons. So the proton count's the same. So I could have another lithium right here, right, with 7, 3. Okay. So this means that lithium has 3 protons plus 4 neutrons. Okay. But lithium here has 3 protons plus how many neutrons? Anybody know? How many neutrons does the lithium in the green have? Lithium in the green. 3 plus some number gives me 8. Equals 8. Yeah, you got it, Gage. 5. So you have 5 neutrons here. This always goes here, the 3 protons. You'll notice there is no charge by this, right? If there was a charge up here that said like -1 or 2 or +1, then we'd have less electrons. But because it shows you a neutral atom, we're going to put 3 electrons here. 3 protons, 3 electrons, 5 neutrons. So this is an isotope. This would be lithium 8. Okay. And this one be lithium 7. Right. So they add the protons and neutrons together, and that's how we distinguish one from the other. All right. So let's look at this carbon here. So 13 equals 6 protons plus neutrons. How many neutrons do I have here? How many neutrons? Yes, 7 neutrons. Protons, how many protons do I have? 6, thanks, Aaliyah. How many electrons do I have? How many electrons? Not sure if you answered. Yeah, 6. Okay, and this would be called carbon 13 because there is a carbon 12 and there is a carbon 14. And the only difference, they all have 6 protons. The only difference is what atomic particle. You had to throw your stuff away. Oh no. So you want me to go back on one you said? Yeah, okay. Anybody know what the difference between carbon 12, 13, and 14 is? What's the only difference between them? Is it the electrons or is it the neutrons? Electrons or neutrons? Nope. Electrons does not make that. That makes an ion. Ions do that. Yes, they're neutrons here. If it said -1, now the interesting part is you can have a charged isotope. So you can have electrons different and neutrons different. Okay, so let's go back one. Here, wait a minute, where is it? I think we just had is this one, didn't we? Wait a minute, where? Yep, that was it. That was it for this one, Braden. You didn't take long. So taking forever to load. Let me do this. Let me take a screenshot of this, and then we'll save it for later, okay? All right, so I'll just have that down besides. Okay. So 353,676. Okay, so as Max is probably you asked this question so much. You asked this question, or the question came up. You have look at this. You have a charged isotope. Okay, so these are isotopes. This is carbon or chlorine 17, and this, I'm sorry, 36, because that's the mass, and this is chlorine 35. But we have no charge here, and we have a charge here, a negative charge there. So chlorine 36 and 35, the neutrons are the only thing different, but we also had a negative charge here. So protons is 17, right? Neutrons, I spelled that one wrong. So we're going to take 36 minus 17. Anybody know what the neutrons for this one will be? 19, right. Electrons has to have one more electron than it did before. How many electrons is it going to have? Yes, 18. Because 17 electrons would make it neutral, 0 charge. 18 makes it -1. Here, this one's 0. So we can put protons 17. How many electrons can we put in here to make it 0? Neutral charged. Yep, 17. And now we're going to take our 17 from our 35 here, and we'll get how many neutrons? Spelled wrong. Yeah, 18. Okay, if you're struggling with this, okay, Thursday is Win Day, so we'll have some extra practice sessions, but we have just basically 2 weeks left before this quarter ends. So let's try to go out with a bang, get a good grade here. All right. Okay, so why are masses of the periodic table usually expressed in decimal numbers? It's because they are weighted averages. And so what we mean by that, all those isotopes make a difference, right? So you would think that hydrogen 1, hydrogen 2, and hydrogen 3 would have a regular occurrence. About 33% of them be number 1, 33 would be number 2, and 33% would be number 3, but that is not what happens. What really happens is this. 99.98% of the hydrogen with only 1 proton, no neutrons, is the most common. All right, the occurrence of hydrogen 2, which has 1 proton, 1 neutron, only a hundredth of a percent. And number 3, almost non-existent. Okay, so I'll give you an example of that. Right, out of 10,000 atoms of hydrogen, 9,998 are the hydrogen 1 with only 1 proton, no neutrons. The occurrence of the 2, you get like 1.5 every 10,000, or for 20,000 you get 3, and then takes quite a few in order to get the number 3, where you have two neutrons and 1 proton. So that's why the decimal place, when it's weighted, okay, it's weighted toward the ones that are the most dominant, right? So most dominant here, 1.007, I think hydrogen is listed at. So it doesn't really have many of these others in there. So that's how you can tell. All right. So how does this affect all these isotopes affect things here? So let me turn my pen off. I guess I have to turn my pen off. Is that it affects the nucleus only, right? The neutrons are the only thing that get affected. It makes the atom have more mass, but it doesn't affect what it looks like. And as far as the shells of the electrons, nothing happens there. Nothing happens there at all, right? Nothing happens at all. Oh, okay. Look at here. So let's look at the electrons that are important. So this gives us a nice segue into Lewis dot. Electrons are important. The valence electrons and the outer shell are the ones that are important for bonding. So that's where we want to talk about the Lewis dot for review. All right, so here is the Bohr atom. Was so boring last week. I didn't bore you by make a lot of drawings, but if you had to make some drawings of the Bohr atom, you have to include every single atom, every single electron. All right, and you had to put them in the different orbits here, right? You had 2 in the first orbit, and then how many left you had here. Here's oxygen, and notice the Lewis dot only has the outer shell, 1, 2, 3, 4, 5, 2, 4, 6, sorry, 6 oxygen atoms. And that's the only ones we have to do. So you can start on the right side or the top, and then you put them in as you go clockwise, and then you double up as you go. So we'll be practicing that today, right? So that's what so not a lot of writing, mostly just practice. All right, so you have a document that shows this up in the corner, right? So remember, let me get my pen back on here. Remember, this number right here is the valence electrons, okay? That is the valence electron. So let me get a different color pen. Let's go purplish. Okay, so I'm going to start at the top, put a dot here. I'm going to make a big dot. Then I'm going to go to the hand side, make a dot, and I'm going to put 7 of them in there. I'm going to go to the bottom, and then the left-hand side. Then I'm going to double up the top one until I get to 7. So I got 1, 2. So is it? Okay, I got 2, 4, 6. I got one more, and then put it down here. So you should have 1 dot by itself. 1 dot by itself. Remember, these are the valence electrons. These are the only ones that are interested in bonding. Now, if I were to draw the Bohr atom, okay, I'd have 53 plus charges, and I'd have 1, 2, 3, 1, 2, 3, 4, 5 electron shells. 2 in the first, 8 in the second, 18 in the third, 18 in the fourth, and then 7. And that's a lot of work. So we're kind of saving some energy here. So we don't have to draw the Bohr atom out, put all the neutrons in here, and all these shells. Okay, we're only interested in that. So, all right, so let me go ahead and turn my pen off here a second. So yours should look like this: 1, 2, 3, 4, 5, 6 with 1 dot by itself. Okay. Are we good to go on this? Do we need to move on? Can we move on, or do you want some more time on this one? All right, Gage says we're good. More time, okay. So you don't have to do this, Braden. You don't have to draw the Bohr atom. I'm just showing you the Bohr atom versus the Lewis dot. Lewis dot just shows the 7 electrons that are for bondings, the bonding that happens with when you have elements that make a new substance. Okay, so you don't have to draw all this stuff, right? Just want to make an illustration there. Okay, so krypton, how many electrons in the valence shell? Thanks, Gage. Yep, there are 8. Okay, so this is what we're going to do. Let me get my, and we're running, oh, we got 1 more minute. So you guys have, okay, so we're going to start at the top. 1, 2, right side, bottom 3, left side 4, top double up, right side double up, bottom double up. Now we have 8. Okay, let's see if that worked out according to plan here. Yep. So we have 8. So you have some to do. I'll let you guys finish those off. So your goal today with the last 15 minutes, okay, is to, let me turn this off a minute. All right, is to work on W1. So W1, I'm sorry, W8, assignment 1. And if you have any assignments that say W and assignment 1 or 2, if you have less than 15, you want to make sure you go back. It's 20% of your grade. So make sure you get 15 out of 15, right? Okay, and finish the assignment. Finish, F-I-N-I-S-H. N-I-S-H, yeah, not I-S-I-H. Finish the notes. Okay, so especially the last slides, those count as more than 50% of your grade. So if you've done what I did, I'll give you 5 out of 10 or 10 out of 20. But if you finish them all, you'll get your extra points there. You won't get all the bonus. All right, so I have a little thing for you today. I'm going to do a magic trick for you. You're saying, Mr. Gale, I didn't know you had magic in you. I didn't know that I had magic in me either, but I am going to show you something. So maybe you guys will notice this. Let me turn off my camera. And I'm going to put this other camera on. Okay. Do this. Turn this camera on, turn this camera off. This is my document camera. All right. Put that over here. Okay, let's do that. Let's get that out of the way. Start sharing. All right, so this is my magic trick for you. All right, so I've got some nails here. Okay, and this happens to be the scratch cardboard for my kitty. Kitty likes to scratch take care of its nails here. So I'm going to show you this in as big as I can make it. Okay. So I am going to take these nails and balance them on the end of this nail. Okay. So I'm going to balance it. So if you can see, it's balanced. So you can notice that they are not magnetic, right? So I can, well, let's see. I don't know if I can even get them to stand like that. So I'm going to balance all of these. How many do I have? 2, 5, 8, 9, 10. I got 10. I got 10. Okay. So how many people think I can do it? Let's see. Start a poll. How many people think I can do it? Balance, right? I'm going to balance. True or false? Let's do it. Yes or no. True or false? False means, okay, I'll make this anonymous so you don't have to think that I don't trust you guys. Okay, so true or false? How many think that I can balance those on top of here? All 10 of them. How many? Okay. You've seen this trick before? I have no rubber bands. Okay, I have no rubber bands. Okay, so I'm going to show you how to do this, right? If you haven't seen this before. First off, you got to make sure you get nails that have heads on them, so you can pound on them. All right, they've got an edge. So you're going to do this. You're going to take a nail and you're going to switch them so they're like this is the backbone and these are the ribs, okay? So you're going to switch them back and forth, back and forth. That one's kind of screwed up there. Okay, back and forth, back and forth. Okay, and then you take this last nail right here, and then you're going to use that as the top part. Okay, and I try to hold it in carefully, like so. And there you go. It is balanced. Balanced. I hope I did not offend anybody here. Notes, assignment 1 and assignment 2, Jackson, are 20% of your grade. Okay. Notes are are bonus points, and they count as 10% of your grade. Okay. Okay. It's a good question, or we can talk about, come and see me in advisory on 225. Okay. We'll talk about that. All right. Well, thank you guys. Thank you very much. You guys trusted me.